This might be a typical exam question we're likely to get in the final exam. So the question asks, hydrogen reacts with iodine to form hydrogen iodide according to the following reaction. And we're given a chemical reaction and we're told we want to know the equilibrium concentration of HI after we have added in 1 mole of hydrogen and 1 mole of iodine to a 1 litre vessel, and we're given a Kc for the reaction of 55.3 at 25 degrees. This particular problem is going to require an ICE table, and ICE stands for initial, change, and equilibrium in reference to the concentrations. Sometimes it's called a Rice table because it's very handy to write the reaction up the top here. So hydrogen plus iodine is in equilibrium with hydrogen iodide, and we need to make sure that's balanced. And then each one of these columns under the component represents the concentration of that particular reactant or product. So initially we're told that we have 1 mole of hydrogen in a 1 litre container. So our concentration initially of hydrogen was 1 mole per litre. Initially we had 1 mole of iodine in a 1 litre container, so it's 1 mole per litre concentration. We're not told about a concentration of hydrogen iodide, therefore it's 0 molar or 0 moles per litre. So now we need to put something in our change column. So we can use a trick of mathematics and say let X moles per litre of hydrogen react. Okay, and therefore if X moles is going to react, that means the change in concentration is going to be minus X molar because we're consuming, because it's a reactant. And if we're consuming X molar of hydrogen, then we're also going to consume X moles per litre of iodine. Now, due to the stoichiometric coefficient out the front here of this reaction, we're going to produce 2X moles per litre of hydrogen iodide. So at equilibrium, if we've had 1 mole per litre initially and we're consuming X moles per litre, at equilibrium we'll have 1 minus X molar. So we're just summing down the columns. 0 plus 2X is 2X. So we have now some equilibrium concentrations that we could substitute into the law of mass action. So let's write the law of mass action for this reaction. Kc is equal to concentration of the products raised to their stoichiometric coefficients divided by the concentrations of our reactants. And that was equal to 55.3 at 25 degrees. Now let's substitute in our concentrations at equilibrium. So 2X up the top there, and 1 minus X for both iodine and hydrogen. So let's just tidy up this bottom here. So 1 minus X times 1 minus X is like saying 1 minus X squared. And because we've got squareds top and bottom, we can take the square root of both sides of this. So we're left with 2X here divided by 1 minus X is equal to the square root of 55.3. So now we just need to work with this equation and get all the X's together and get all of the numbers together. And this is the type of mathematics that will be required in this course. Get all the X's together. Now we can use a calculator and work out that our X is equal to 0.788 moles per litre. So at this point here, a lot of students would rejoice because we have an answer. And if we go to the multiple choice answers here, we can see that A does indeed look like it lines up with that amount here. But if we look at our equilibrium concentrations, we can see that the concentration we want is 2x, not x. So we want to work out the concentration of hydrogen iodide at equilibrium. We know that's 2x, so it's 2 times 0.788, which is equal to 1.576 molar, or in our answer 1.58 molar, which is actually answer 2, not answer 1. Be very careful of that when you're answering these questions.